Okay, so hello and welcome. I'm Dan Kurger. I'll be your MC today. Today's webinar is going to walk you through many of the enhancements in the highly anticipated and imminent release of Femap 11.3. Our host will be Rachel Backus, one of our Femap experts here at ATA. Many of you met her actually during our recent round of Femap symposia that just wrapped up last week in Denver. But before I turn it over to Rachel, let me give you a brief intro to ATA. Most of you know ATA either through our role as a Siemens partner and reseller or through our robust engineering services. It's our experience in providing engineering services across a wide range of industries that allows us to put the value added, if you will, in value-added reseller. Solving many of the same issues in the same industries as our software customers allows us to provide exemplary support to those software customers. On the services side, our focus is on analysis and test-driven design. Whether it's performing ground vibration tests on state-of-the-art aircraft, or analyzing the next generation of spacecraft and planetary rovers, or even helping to ensure the safety of roller coasters and other entertainment park attractions, ATA is here to help our customers meet their toughest engineering challenges. And of course, being experts with Siemens PLM software helps us to do precisely that. Speaking of using that software, here are the Siemens products that we use and can help you out with, whether that's through me helping you out with licensed sales or engineers like Rachel providing first-tier technical support, or by training your engineers to use these tools to their fullest capacity. I'd particularly like to point out that ATA developed all the training materials for NX Nastran and are recognized for their unique depth of experience with this solver. I only wish that there was a website where you could easily find your schedules and class descriptions conveniently. Ah, well, there you go. Many of you have already seen this website. In fact, if you registered for this webinar, you are, of course, pointed here, and hopefully you'll do some digging around. Here you'll find software product information, links to download free trials, like a 45-day free trial of Femap, links to information on our upcoming training classes. The list goes on and on. For existing users of this software, you'll find a link to our hotline, to our support hotline, and an ever-expanding array of free resources, everything from white papers, training videos, tutorials, APIs, you name it. And that is a continuously adding list, so growing list. So we want to hear from you if there's specific resources that you'd like for us to generate. I invite you to check out these resources after the webinar, but without further delay, I'd like to turn it over to Rachel for the main event. Rachel, take it away.
Thank you, Dan. Hello, everybody. So my name is Rachel Backus, and I'm a project engineer here at ATA. So that means that not only am I an engineer and working on projects just like you guys, but I'm also responsible for doing training and technical support and all of that fun stuff. So I'm here today to talk about the new version of Femap that's coming out. Let's see. Dan, have you sent over?
Yep, you are the host, so you just need to share your screen.
All right, there we go.
Okay, and there it is.
Okay, we should be good to go. All right, so here's a quick outline of what we're going to go through today. There we go. I'll give a quick introduction, and then we'll jump into some examples so we can get in there and see what the new version is really like. So I've got 4 examples for us, one focused on some of the new visualization techniques, another one showing the contact, another one showing some mesh refinement options, and another where we get to play with some post-processing. And then I'll jump back into the PowerPoint, and we'll look at some of the solver support updates that were made. And then finally, at the end, we'll have a question and answer session so that if I skipped over anything too fast, then you can ask me questions. So the new version 11.3 was supposed to happen this week. It turns out that they're still working on getting some beta type bugs out. So they're hoping for the end of April. I talked to the developers last week. They're saying sometime between now and then. So keep an eye out for the email, and then you'll have links to the Siemens GTAC website to get the download and all that information. And in general, the Femap direction from the developers, they want to keep it really dedicated to finite element and be really focused on a finite element environment. So while they're trying to increase some of the functionality and the features, they really want to focus in on that sort of environment, not so much the general CAD and assembly type things. So their real focus is to create detailed functionality so that you can accurately model what's going on in the real world. And the other thing they're really focused on, and if you were at any of our symposium meetings, you heard them talk about this as well, is they're really focused on customer-driven features. They want to hear, what helps you and what features you want to see in the future. And they're really focused on getting those in as quickly as possible. So let's jump into one of our examples. So we have here part of a wing, so we can work with and do some visualization. One of the new features you'll see up at the top is the DryErase toolbar. This is something a lot of people have been asking for. Basically, it'll let you change what you're seeing and what you're looking at very quickly on the fly. You're not saving groups or layers. So we'll just turn on erase, and then I'll just go by some of our mesh options. So maybe I want to turn off this top property so we can look inside. So that'll just turn that off. Then I can go in back and select some elements. Maybe I want to hide some of these guys as well. You have some other options here like grow and shrink, which can be very useful. So I could grow and erase more elements. And then I can quickly toggle, so I can show either what I'm erasing or draw what I'm erasing and flip to the other side. We have those options. The same things work with geometry as well if you have geometry in your model. And then we can clear the selection and restart again, or if you're not interested in using this for a while, you can turn it completely off. Another useful tool is we now have, if you right-click on the screen or go up to your view options, you now have this pick front option. So let's leave it off for now. Normally, if I were to select elements to show, if I draw a box around part of my model, you'll see I grab the elements in the front, but I also grab everything behind me. This is what you're used to doing in Femap. Now if I turn on this pick front option, we'll do the exact same thing. So I'll show elements and just use that box select. And now instead of grabbing everything behind me, it just grabbed what was on front. And so to speed things up a lot, the Femap developers made this just look at the pixels. So if you're zoomed really far out and your element is smaller than a pixel, you may have some problems. But generally for models, this can be very useful. This also works if you're just doing single select. So as I'm rolling over now, you see I'm always grabbing that front element. It's being highlighted. That can be very useful. Another really cool thing that they added is an option called roll through. So before, which you can get to from your view options, before if I zoom in and zoom in and zoom in, that element just keeps getting bigger and bigger. I never get inside the model. I can turn on roll through, and then as I zoom in, you can see it starting to slice into that model. And I can actually go all the way inside and spin around and turn around, look at the side, look at the front, zoom back out. It's definitely a very interesting tool. So that one's kind of exciting. And you'll notice when I'm in here, they also added a lot more rotate options. So there you have options to rotate around axes or coordinate systems, pretty much whatever you like, whatever is going to be most useful. And all of these features can also be accessed through an advanced rotate pane. So I'll let you play around with that on your own. We'll turn roll through off by selecting another option. And we also have a couple new tools. So you can access these. I added on buttons for zoom around cursor and rotate around cursor. But you can also access these through the file preferences. And then in the user interface section under mouse interface, you have the dynamic zoom around cursor and rotate around cursor. They'll do the same thing. So if I toggle them off, this is as if we were in the old 11.2. Now when I zoom in to my model, no matter where my cursor is, it just always goes to wherever my view center was. If I turn on zoom to cursor, if I put my cursor over here, then I'll zoom into this corner. I can zoom back out, and I can just move my cursor over to the other side, and it'll try to zoom wherever my cursor is. The same effect with rotate. So with rotate off, it just rotates around wherever the view center is, no matter where I am. But with rotate around cursor on, it'll try to grab the point of the model closest to my cursor. So if I grab there, it'll try to rotate around that corner. Now if I want to rotate around this corner, it'll swing there. And this can help a lot when you're zoomed in really far. You won't have the model swing out of view. Another thing, not so much visualization, but I want to show you with this model, are the properties. So you'll notice when I open my Properties tab, we have some nice icons here. So this is new, and so it shows you, obviously these four materials are plates, and these are beams. Some of them are L sections. So it gives you a very nice visual, especially when you have a lot of properties in your model. Now if I want to go and edit one of these beams, this page looks the same. When I bring up the shape, you'll see this is quite different. So we have all of our properties here, so you don't have to be canceling out and checking your area and coming back in. You can just update them. So if I want to change my height to 1.5, let go. Most of these updated. If I want to make sure they updated, I can compute them all again. And now I have my full set of properties. We also have the rulers on here so we can see our size. And if I wasn't sure what some of these labels were, then I can click down here and there's a cross-section help diagram. And it tells me, oh, okay, this is the height, and thick bottom refers to this thickness versus just thickness refers to the side. If I want to go back and see my section, I just hit draw a section. Another useful tool here is you can export pretty much an image of your property. They call it a property report. So I can click here and say copy section, report to clipboard, go into Word, and paste it. And you'll see a summary of the properties plus that drawing. So again, very useful for reporting. Just cancel out of there. So that's some of the visualization tools that they updated for us. Let's jump into a contact example. We've just got two plates here. They're restrained on either end. There's a load on the top plate pushing down. We have a new manager. So if you go into Tools, we now have a connection editor window. So this is like, our data table or any other type of editor. And it'll list if we have, 50 or 100 connections in the model. If it's a very complex assembly, they'll all be here. So let's just use it to create a connection region here, a contact region, and run. So I can right-click in the window. And this gives me some of my options for creating new connectors. I know I already created a property earlier, so let's create some regions. So this looks about the same as before. But if I click Add Multiple for my elements, they changed the face selection toolbar quite a bit. And hopefully it's a lot more useful. So first of all, the method now defaults to adjacent faces instead of face ID, which is what most people ended up using anyway. But just so that you're aware. And then I can select, instead of grabbing from the whole model, I can say, well, instead of selecting from the whole everything, let's just look at the elements in this area here, which is where my contact is going to be. So I can see, as I'm scrolling over now, I can see which face I have highlighted, and it won't let me select elements out of that area that I defined. So we'll put a region here, and now highlight also now shows you all of the elements that you selected. So we can say, okay, let's call this bottom And we'll have to create another one for the top, so I'm just going to click through all the same commands again. Make sure I got the right ones. Okay. I forgot. And then now let's create a connector. So I can go in here again, add a new connector, grab my two sides. Like I forgot to title one, but we will fix that in a minute. Let's call this connect one. And we created it. Now it shows up in our connection editor. So it's really useful as you do on-the-fly changes. So I wanted to change that guy, I could. Just edit in here. And it lets us select our property, it lets us turn it on and off if we want to change the status and all of that. So let's just hit go and we'll run an analysis and see what happens. Make sure we have it set up properly. Should just take a minute. All right. So we have some results. I had one in before. I know that one was old. We'll just call this contact. Now let's say we wanted to also run this with glue. I could easily go here and say, okay, I want a new property. I could right click and do properties. I can also access in the old manager by clicking this other button. And I can select a glue property if I wanted to create a new one. I could do that here. And this will update it. And then if I run again, now I have it set to glue. So that's all the change that I needed to make. So once this runs, we'll take a look at both of these. Go ahead and close my editor for now. Bring up post-processing. Go ahead and deform our model. Turn on some contact. All right, so here was our contact run. You can see it's just pushing down. And there's our glue. Another couple changes that were made were to the free body. So before, under your contributions, you didn't have options for contact and glue. Now we do have options for those. So before, if you tried to sum all of your total load on a piece that was in contact, it may not have summed to 0 because it wasn't including that contact contribution. So let's turn some stuff on. So we have our applied, and let's just bring that total summation vector up a little bit more so we can see it. So we have our applied load. We can mix in our reaction, and you can see there's still some element that's not 0. So now if I turn on my contact contributions, you can see where the contact's happening, and then this summation vector showing that we're pretty close to 0, just a few rounding errors. Similarly for glue, we can go to our glue result, and you can see I don't have glue on right now, so we're just seeing the applied in reaction, and there's some loads that aren't summing out. And if I turn the glue on, that will come to 0. And if I just wanted to look at the contribution due to glue to see what the shear and normal reactions were, there we go. So I have my total, I have my arrow plot if I need that. So that's all in free body. There for you. All right, so let's switch over to the mesh refinement example. Right now I have a part here, it's just normal quad mesh, nothing new going on. If I go to model info and I look at my elements, I have a lot of triangular elements scattered throughout my model. But we know triangles aren't great all the time. Sometimes they like to focus, bring load in, create stress concentrations. So maybe I really want to try to get rid of those. Well, we have an option now to do that. So under the meshing toolbox in mesh surface, we have a max quads option. So I can turn that on. Let's not change the sizing. And we'll just grab all of the surfaces here and see what happens. So remesh. Now let's go highlight again. And you can see it got rid of almost all of the triangles. Now there are a few over here, a couple areas where you really would want to use a triangle. It would be way too distorted to try to put a quad in there. And then we have one set over here where it didn't quite work. And you could see you could probably easily get a quad in there. Maybe its aspect ratio was a little off or something. But we can get it to work. So we can go to mesh sizing. Since I have two triangles here, I'll need to increase or decrease one of my curve sizes by an even number. So we'll just increase it by 2. And we'll just pick this curve. Now if I go check again, you can see that those triangles were fixed. And so now we have quads pretty much everywhere throughout the model. Now you can see we have this big area where we probably don't need small elements throughout the whole thing. When you had triangles before, or similar elements, you could, allow there to be bigger elements in the center. You can now do that with quads as well. It's called the surface growth factor. And so let's just double that and see what happens. So I can grab this surface. And so you can see now we have twice as big elements in the middle and our smaller elements out near the edges still. Another nice tool we have, well, you'll probably want to remember this, is under Mesh, Editing, there's now an Element Refine. So this is kind of another couple steps advanced from our other Element Refine and Split Elements tools. It's pretty much a paintbrush. So I can say I can do 3x3 or 2x2, and I can just click and drag to increase the element size. And right now this is just kind of painted on. It hasn't been finalized. So I can do things like grow or shrink. I can start over if I wanted to and clear the refinement. You have some other options for splitting edges or doing a directional edge split without having to first figure out your element orientation and then do the split. So those are all in there. And this is painted on right now, that's why it's highlighted. And as soon as I click OK, then it'll finalize it. And that's also useful for around holes. So if we wanted mesh refinement there, I could say, let's refine and pick elements on curve. We'll just pick those two curves, and it'll grab those. And we can grow it out if we want to, or shrink it back to where we were. And when we like what we see, we just hit OK. So that makes mesh refining very, very easy. Now before, let's say we wanted to remove this split here. We had some geometry cleanup options. You could go to combine and boundary surfaces, do the add by curve, and what you'd end up with is not a parasol surface, but a boundary surface. Kind of the same idea with removing points, as you could go to composite curves and create this composite curve structure that referenced the underlying curves. But now we have options to actually edit the parasolid geometry within the toolbox. So this would be a permanent change that you can't easily clear or delete. You still have the old options if you want that ability to go back. But if you want to actually make changes to the geometry, then you can do that as well. So those options are under feature removal. So let's say we want to remove this split edge here. I would select curves. And then under curve options, we have our basic and aggressive as before, but now we also have combined surfaces. So I can select that, I can select that curve, and now it's gone. And this surface is, a parasolid surface. It's actually there. It's not a boundary surface referencing the old one. Similarly, I could remove a point. So I can go to point. Let's just get rid of this guy here. And I'll have, we can list this curve just so you can see that it's an actual curve. It's not like before you'd be referencing two other curve numbers. This is the actual part of the parasolid geometry. So we have that as well. So we made a bunch of changes to this mesh, and maybe we want to go back to an old numbering scheme. So we can do that. Now there's a modify, renumber all option. So before you had to go nodes and then you had to renumber elements, you do each one by one. Well, now we could renumber everything in the model that we want to. So we have, our geometry. Let's go ahead and renumber that. We have our mesh. Maybe we don't want to do properties, materials, and we don't need to do groups and layers and other things. We can use the same starting ID for everything, or we can check this box and give custom starting IDs for different types of objects. You'd still have your offsets options as well. So let's just renumber all of them and hit go. That's it for meshing. So our last example is looking at some post-processing tools that were added. And the big one of these, you'll see up here, are contour arrows. Now there were contour arrows before. I can't remember what they were called, and they weren't very useful. They were kind of difficult to use. Well, that whole part of Femap has totally been revamped, and now we have some really nice contour arrows. So just turn on. So if you have on Mises stress, it'll just show you a magnitude, and it'll just take kind of the element orientation as is, or direction. But this is also kind of smart. So if I want to grab something that has some direction, maybe plate normal stress, instead of just bringing up the plate normal stress, it brings up the X stress, the Y stress, and the shear stress. And it tells you down here which ones it's showing, or up here. And I could say, okay, I don't want the shear, so I can turn that one off. Maybe I'm having a hard time seeing which is which, so I could turn off my contour colors and just see the red, blue, and green. This also has some nice tools for transforming. So you have a transform section here. Instead of using the local element coordinate system, I could say, okay, transform everything into basic rectangular. So now it'll fit that as best it can to the plate orientation, or any material direction, or any of your other options. We can also choose something like principal stresses. And if you turn back on auto, because we made some changes, then it'll auto update all of your settings. So now we're seeing kind of compression, tension arrows. You could make them solid or not. Again, you have a lot of options here to make things look exactly the way you want them. And they automatically, with the principal stresses, you can see they automatically showed up at the correct angles as well for each element. These options also work for beams and springs, so 1D elements. So we can look at maybe beam axial force. We have some beams in this model, some ribs. You can see again it pulled up some other options for you. So we have the axial force and the tension compression arrow, and we also have the shears. Now let's say we wanted to, this is great for visualization, we can make a nice picture, but let's say we want to send out the data. We can bring up our data table, unlock it, and then we have list, output, contoured results to data table. And before you go there, you'll notice there's a lot fewer options in here for some of the force balance things. All of those features are still there. They are just now combined under a single force balance. So if you open up this menu and go through it on your own, you'll see all of those options are still there. We're going to use this contoured results to data table right now. And so it's just going to send everything that's contoured on the screen right now, all those beam elements, to the data table. So now those appear, the element numbers, our axial force, and our two shears. And we can export this like normal and edit it and do all of our things that we normally do with it. So those are for examples. You can see there's a lot of new stuff, a lot of fun tools to play with. I hope I'm getting everybody excited about the new release coming out. Let's go back to the PowerPoint. We'll talk a little bit more about post-processing and connecting to solvers and some of the more nitty-gritty details and things that have been improved. So one of the things is you can now have results titles and case title or study titles automatically generated with custom titles and labels and that sort of thing. So this can be found under Preferences, and you'll go to the Results tab, and then you have study titles over here, and you have output set titles over here. Some of this was in 11.2, some of it wasn't. You can now track revision, use the subcase IDs so that it'll say, pull out a C, and then the case number, subcase number, an R, and then the revision number. And it'll track and say, okay, how many times have I ran this case? Is it revision 1, revision 2, revision 3, and so on? And it'll do that counting for you. So it's a little bit confusing in here if you don't know what title, subtitle, label, all these refer to. What they actually refer to is if you bring up your analysis manager, you have an analysis set title, a master title and label, and then a case title and label. And down here I made a little key. So at first it looks for the title, it'll always grab the analysis set title. For the subtitle, it'll try to grab the case title. If this hasn't been defined, then it'll look at the master title. And if neither of these have been defined, you'll see unknown written out. And the same idea with the label. You can get the idea of what they're talking about. So another new thing, there's now support for attaching abacus ODB files. So if anyone uses abacus here, that's good news for you, I'm sure. It supports all the prior versions of the ODB and works very similarly to all of the other file formats that can be attached. Again, they're fully compatible with all the normal post-processing functionality. Another big thing in Femap is now we can define SPCs with non-zero displacements. So, in other words, non-zero constraints or enforced displacements. So you just go into your normal nodal constraint window, and now there's a non-zero constraint button. And if you open that up, then you can define your non-zero constraints. So this is the alternative to creating a constraint on all your enforced constraint nodes and then going and applying it as a load enforced displacement. Now it makes a lot more sense. And when that's written out to the file, you'll see these SPC lines with your enforced displacement distance. There were some other changes made to your executive and solution options for NX Nastran. You can add an additional command line, and you can actually create a preferences default. So if you're constantly changing your amount of memory or other settings like that, you can set it in your default preferences and it'll automatically load here and you can edit as needed. The other thing the developers have been working on are trying to add a little bit more GPU control. So you can help with your computing there. Right now they only have a couple options, but they'll be putting in more options as they become available in future releases. So that's where you'd access this. So another big thing is that before, or if you're working in ANSYS and Abacus, there's no C-bush spring element. And so if you're trying to translate a model from Nastran into ANSYS or Abacus, those elements would essentially disappear because there wasn't an equivalent. Well, one of the big things the developers wrote was this methodology for taking that C-bush element, calculating a general stiffness matrices for it, and then exporting that into ANSYS and Abacus. And all this is done behind the scenes. It's very seamless. So you don't need to know how all this works. Just know they kind of figured it out. So if you have the normal C-bush window up for a Nastran element, all of the stiffness values will get merged together into a K-matrix, and then the structural and regular damping will get merged into the damping matrix. If you have all of these defined, then you'll end up with two elements in your ANSYS or Abacus model, one with the spring matrix and one with the damper matrix. And you'll see those as just general matrices, matrix type elements. the matrix 27 ANSYS, and the matrix input in abacus. One thing to note is that these matrices are calculated only once at the export. So if you're trying to do a nonlinear run, nonlinear within this material property, or put in any frequency dependencies, these end up being ignored. And to support this, the developers also had to put in a general stiffness matrix that was 12 by 12, so even larger than the previous 6 by 6. So this is also available for anyone within Femap. If you really want to get into the nitty-gritty details and define every single stiffness value for your element, or damping or mass, works for all 3 types of matrices. And then another kind of exciting element type that was added in are your spring to ground elements. So instead of always having to have 2 nodes defined on your spring and your spring between those nodes, and then maybe adding a constraint at one end or the other, now you can just say spring to ground on one node and call it good. So you have the C-bush element types and the regular DOF springs as options. And then the other thing to note is if you do have a 0-length spring element, which is essentially what a spring to ground would be, you need to define an orientation coordinate system. So make sure you select this box option and pick out what your orientation is. Yeah, so that's, I kind of rushed through, and there are a lot more other new features and tools and probably things that are more specific to what everyone does, so make sure you read through the help files when they come out that tell you what all the new features are. This was just a quick summary of a lot of the things that I found more interesting. I'm going to go ahead and unmute everybody in just a second and allow for questions. All right, so got a little louder. Everyone should be able to talk now. So did anybody have anything they wanted to ask?
Hey, Rachel, I've got a quick question. Can you hear me?
Yes, I can.
You know, I'm a relative new Femap Nastran user, and I got a question. Something you just brought up there, which was under a defined property where you showed the stiffness matrix.
Uh-huh.
I have never seen that before. How did you do that?
How did I bring
right
up
there.
this? Oh, that matrix type? Let's go in here. So if I just define a new property under element property type,
Okay.
we have this general matrix under other elements. If I remember correctly, this was in there before, but it was a smaller 6 by 6. But I can click on that, and this is what you would have seen. This is a 6 by 6 stiffness matrix. And now if you want to go to the 12 by 12, they have a new button here that would open up the full matrix.
Okay, so is that allowing? So going back to the previous pop-up, and I can't think of the name of it off the top of my head, but no, before that, it's when you when you actually chose the element type. Okay, so we're looking there at element / property type, right? And I'm a composite guy, so I normally would choose, a membrane element, for example. But this is different from choosing a plane element. This is actually, or are you actually seeing what the matrix is for what other element you have selected? Is this where somebody would physically go in and enter their own unique matrix?
Exactly. Yeah. So if you had, some crazy type of element that's not, not a normal beam or bar or something, spring or something else, and you just want to do a very specific type of stiffness or maybe mass matrix or something like this. When you get into the nitty-gritty of the linear algebra behind finite elements, that's where these are going to be used.
Okay, so you were able to actually view. You were able to view the stiffness matrix. That was for entering your own stiffness matrix.
Yeah, this is for entering your own.
So on that previous slide that you had, that was something that you physically entered yourself.
Yeah.
Okay, I gotcha.
Yeah.
Okay, and then I've got one last question. So towards the end of your presentation, actually, when you had that wing box up there, okay, well, now that you're looking at this, so you're telling me you physically entered those yourself.
Yes.
Okay, I gotcha. Okay. Back when you showed that wing box and where you showed the stresses or the loads in the XY direction, and then you showed the shear, that was under the form, that was under your results?
You're talking about these arrows that I'm showing here?
Yeah, and you actually had them, you had them, it was prior to that display. It was one of the other previous examples where you selected arrows. I'm not sure what your, what vector you were showing, but you actually were showing like the stresses. You were showing the axial stresses and the shear stresses.
Yeah, so we can bring up the plate top stress and make sure my transform's turned off. And so this is showing the red is going to be your X normal stress, the green is your Y, and then the blue is that XY shear stress. And if you go up, and you can see kind of in the post processing toolbar here which one's showing up as X, Y, and Z. So I can And that's a free body thing, or that is a contour results thing? It's a contour results thing. So it's called contour arrows. And so up in here where you had your criterion contour plot and all those others, now we have this contour arrow option. Okay, and so that is new. Contour arrows is new? It's fairly new. It existed before, but it wasn't nearly as kind of merged with everything else as this is.
Okay. Well, that's a beautiful thing right there. And so what you did to show that was you selected, the output vector that you're actually showing, it seemed like you only selected one.
Yep. So it's smart. It knows, like if you select, something that goes together, if I want to do total translation, for example, if I select total translation, it's going to show me the vectors. Oh, let's see, maybe it didn't do that. I think we have I'm still figuring this out too. I've only had it for a week. But it'll figure out kind of what, if you do a total thing, it'll figure out what else you probably want. So if I do like this beam axial, all I selected was axial force, but now I'm getting my shear vectors as well in these beams.
Right. So before you selected, you just selected stress. What did you actually select before? You selected...
So I went up here and selected my output vector. So this is the same, contour output vector that you normally use. And so I just got up here, pick what I think I want. So this one was axial. I could do my major principal stresses or my X normal stresses. But you select one kind of from the group that you want to view, and it'll automatically bring up the others for you. Okay.
So by selecting X normal stress, it automatically grabbed your Y and your XY shear.
Correct.
Oh, wow. That's really nice. Really nice. Okay.
Yep.
Well, very good. That's the only question I have. That's great.
Is there anyone else want me to show again real quick, or that they had questions on? All right. Well, I'll let everyone get back a little bit early. Definitely appreciate everyone coming out and watching. 11.3 will be available for download when it's released, which will be by the end of the month. So,
Hey, Rachel, if nobody else is going to ask a question, I'm going to. Hey, could you show a little free body stuff?
Yeah. So let's bring back, I think the contact one's where I'm set up in, so we'll bring that back. Yeah, so here's, if you haven't seen this before, I think this will probably be reviewed for most people.
Okay, so that is, okay, well, yeah, that all makes sense. you know, while you have this brought up, I have a glue question to you, because being a composite guy, we do a lot of adhesive bonding. You know, I am not, well, like I said, I'm kind of a new Femap guy, so under the properties for entering this adhesive, you know, you kind of ran through how you did, you know, how you actually defined that bond, you know, previously in this example.
Yeah, so if you're, and this is specifically if you're, not if you're working in, say, a layup, but if you're actually gluing plates to each other.
Exactly, yes, exactly.
Yeah, then it's in the same, kind of the same realm as contact is what you'll think about using. But you'll have what you'll do is create a glue property. So let's just create a new one so you can see what the window looks like. So you have a connection property, and it'll default to contact. But you can change this to glued, and then it'll open up your options down here for search distance, what kind of glue you want to do, and other sort of things. And I would recommend that you go view the help file on this to get the kind of the details of what all the numbers are doing, because I don't know all of them off the top of my head. But that's where you would go about doing that.
Okay, and that was all under defining a connection. Okay, okay.
Yeah, and so if you were in your normal tree, that would be under, oh, I have to cancel out of this. Under connections up here towards the top, you have your properties, your regions, and your connectors. So the property is what's going to define if that's contact or glue. And then your regions will tell you where it goes, and then your connectors will actually tell you which regions to connect together.
Okay, okay, I got it.
Yeah. And I did see a question pop up about the API, and specifically API with free bodies. I know that I did ask them if they had updated the API to include some of the new features like the DryErase toolbar. I did not specifically ask about free bodies, but that's something that I can ask the developers and get back. I believe that was Greg that asked that question. So.
Yes, that was me, yep.
Okay, that was you, okay. Yeah, we can get more information to you on that, for sure.
Okay.
I'm not sure exactly. I would assume it's all supported somewhere, because almost everything is, but we can look for specific things if you haven't been able to find them. All right. All right, well, thank you again, everyone. Like I said, this will be coming out soon. I think there's a lot of fun features, so I'm hoping everyone downloads it pretty quickly and gets up to speed on it. I think a lot of the kind of moving around and rotating, especially that rotator on cursor, is one of those things that you don't really notice until you really start using it. If you're used to having it in other programs, it's really big here. I know a lot of the people around the ATA office were very excited to see that happen. So some of those things. Anyway, have a good day and a good rest of your week. And as always, contact us if you need anything, you know, questions, technical support, whatever. We had our contact information at the end here, you know, the PLM website, the regular ATA website, the helplines. You guys know where to find us. So thank you again. Have a good afternoon. Bye-bye.